Okay, suppose you're given this differential equation. How do we solve this? Well, the way we solve it is by relying upon the following solution that xy will look like C1 times one eigenvector, which we call V1, with lambda 1t, which is the eigenvalue, plus C2, the second eigenvector, and e to the lambda 2t. So I demonstrated last time why this will give you a solution, right? So that this is the formula that we're going to use to solve such differential equations. Okay? So let's try it. Solution. Because this is the solution, that means we first have to look for the eigenvalues and then figure out the eigenvectors. And after figuring out the eigenvectors and eigenvalues, we plug them in here, and that's it. Okay? So we write down first the matrix form of the differential equation. Write down the coefficient matrix, which is 2, 2, 1, 3. Okay, so that's our eigen. That's a matrix form of the system of equations. Now let's look for the eigenvalues and eigenvectors. All right, what do? You subtract lambda off the diagonal. And take the determinant set equal to 0. It's AD minus BC, so 2 minus lambda times 3 minus lambda minus 2 times 1. If I FOIL this, it's lambda squared minus 5 lambda plus 6 minus 2. So it's lambda squared minus 5 lambda plus 4, which factors into lambda minus 4 and lambda minus 1. That means this is 0 and lambda is 4 or 1. Now each of these eigenvalues will have an eigenvector associated with this, so let's find individual ones. So lambda equal to 4. Plug it back in, you get 2 minus 2, 2, 1, 3 minus 2, times some a and b. This is, we're looking for the eigenvector associated with this. And I have to set equal to 0, 0. What's that? That's 0, 2, and that's 1, 1. Oh, sorry.
Wait, why are you not?
Subtract 4, right? Made a mistake. I immediately knew that I made a mistake because the two equations gave out something totally different. Okay? So it's good to know that if you do it correctly, you should be getting two equations that are the same. Now you have negative 2a plus 2b equal to 0, and I see that if I say a is 1 and b is 1, that will give you a perfectly fine solution to it. Okay? Notice that this will always give me infinitely many solutions, so your goal is to find simplest pair of integers that will satisfy. So I choose 1, 1. Okay? So that's good. So we found out that for this, 1, 1 is a good eigenvector. Now what do I do?
Lambda equals 1.
Lambda equal to 1. Plug it back in. I get 2 minus 1, 2, 1, 3 minus 1. And a, b equals 0, 0. So I get 1a plus 2b equal to 0 if I just read the top line. Right? And so here's a nice trick. If it's hard to figure out the value, what you can do is you can switch these coefficients around and put a minus in one of them. So 2 goes into A and 1 goes into B, but I'm going to negate that 1. So if I put 2 here with negative 1, it gives you 0, right? That's a quick way to figure out a pair of numbers that will give you 0. So what's our eigenvector for this one? 2, negative 1. Oh, so we're done. That was much easier than expected, right? So what do I put here in the formula? Here, 1, 1, and then 2, -1. Right? And then for here, what do I put?
4.
4. For this, 1. All right, so that's the solution. However, if you just memorize this and don't think about what this means, then often you're going to miss the point, okay? So here's another way to look at the solution. See, the original solution had nothing to do with matrices. You're just given a system. Right? Therefore, when you're writing your solution this way, you should also be prepared to write your solution in a way that it doesn't use matrices. So let's try to do that. What does that mean if I write this without a matrix? So first, just multiply these two individual ones, multiply them, and see what you get. So C1 times 1 times e to the 4t gives you C1 e to the 4t on the top. C1 times 1 times e to the 4t is also on the bottom, plus C2 times 2 times e to the 1t, so it's 2C2 e to the t, and -1 times C2, so it's -C2 e to the t on the bottom. And then if you add these and set it equal to x and y, you get x equal to what? X is, can you read the right side? X is?
C1 e to the 4t plus 2C2 e to the t.
Y is?
C1 e to the 4t minus C2 e to the t.
Okay. So that's what this is saying. So you should be able to write down the solution in this way and also in this way. Okay? Now, how would you check that this is a solution? You just plug it on the right side. Okay? So if you differentiate this and plug it on the left side, and if you simply do twice of this and twice of this and you add them together, you're going to see that it indeed satisfies the first one, also the second one, okay, for this sequence. I could also have given you some initial conditions. So I could give you something like x of 0 is 1 and y of 0 is 2. In that case, you have to plug in those conditions, and you're going to get the two equations for C1 and C2. So we're going to do that type of question on Monday, and that's it.